Hey everyone, good morning. Happy Sunday. Hope you're well. I'm so happy to have just wrapped up a pregame session over on Instagram. So I hope that you've made the move over to YouTube because I am going to be doing the class here on YouTube. So thank you so much for joining me on this beautiful Sunday. This is the kickoff session to the Introduction to Statistical Learning book that we're going to go through. My intent is to go through for the next 8 Sundays. We're going to be doing a live class that's going to cover all of the chapters as we go along. So my intent today is to cover chapters 1 through 3, and then we're going to do 4, 5, 6, and so on all the way to chapter 10 in 8 weeks. So I'm so excited to see everyone. I've been working on my educational setup here locally with my machines. I've been developing a deck. I'm going to be bringing some new things to you. So I'm just really excited to get started. Really happy you could join me. If you're not able to join every single session, that's okay. I'm saving the replays here on YouTube. And then I'm also adding my own, I'm going to add them all to their individual playlists so you can always refer to them in the future. But yeah, so just really happy to see everybody. I am streaming on a couple of different platforms that do allow for the longer format, but the primary platform will be here on YouTube. And I'm already seeing some people in the chat, and you can see the chat up here over my shoulder. So let me also emphasize that you are welcome to stop me and ask questions at any time. I'm very big on interaction back and forth, and also it's possible that I might overlook a question or overlook a particular concept in the book or something that I'm not explaining clearly. Please feel free to stop me. I do not mind that at all. So, just kind of want to make that clear from the beginning, just to make sure that everybody is comfortable, with understanding and kind of how we're going along. But like I said, it's the Introduction to Statistical Learning book, obviously a very important text when it comes to the world of data science. And I want to make sure that one of the things that I'm really big on is I'm really big on being intellectually honest, right? I don't want to steal any of the author's work. So I want to thank the authors of the book. And I hope to be building upon what they've already published, not copying, but building upon what they're doing. So I hope to be, paying them the proper respect with that. And, hopefully you'll see some new things as we go along, because I'm going to be, kind of adding my own thoughts and whatnot. Okay, so to kick off, I want to make sure that I address some of the chats. We already have an active chat. We haven't even started. We have an active chat, so that's wonderful. And again, feel free to stop me at any time. So let me make sure I look at some of the chats, and I can pop them up on the screen here. Actually, first chat is from Patrick. So Patrick is going to be acting as our moderator today. He's going to be helping me in the chat, just in case I miss anything. So thank you for that, Patrick. Llama Land says, hello, been waiting all day for your live. Oh, thank you so much. I appreciate that. Yeah, I mean, for me, it's morning. For me, it's 8 a.m. in the morning, but I do realize that for some people, it is later in their day. So thank you so much for staying up with me. Giuseppe says, saw your post yesterday on IG, and I'm currently reading the book. So excited to learn more about it. Yeah, right now is back to school time in some parts of the world, and a lot of parts of the world. So I'm getting this comment a lot where people are saying, oh, I just bought the book, or my class is in the second week of the book, or something along those lines. So yeah, so I'm glad it's lining up for you there, Giuseppe, and maybe I can just kind of give a different take on what you're going to learn in other ways. And like I said, I'm going to be adding my own twists and turns. I'm really excited to be showing some of those very shortly. It's going to be in some of my early slides, okay? 8G-Man says, looking forward to this. Thank you, 8G-Man. I'm looking forward to it too. Tariq says, will you post this as a video as well? Yes, absolutely, Tariq. Like I said, it's going to be on my YouTube. The replay will be on my YouTube. And then I'll post an alert on Instagram when that replay is available. It should be right after this session ends. And also keep in mind that the last time I did a class, we went for 2 hours. I expect that we're going to do something similar. So, if you have to step away, that's okay. Come on back. Maybe you missed the first hour. We'll probably be here beyond an hour. So come on back, check in, and you can pop in late. No problem. Patrick, thank you so much for the assist there. Appreciate that. Joseph, hello, Dennis. Hey, Joseph, how are you? Good to see you again. Issa says, I hope next week we can have an overview of what topics will be discussed. I am still on chapter 2 right now. We're going to do that today. I'm going to start off with the philosophy and my goals for the class. and we'll go from there, okay? Tariq says, awesome. I'm currently traveling and can't join today. I greatly appreciate this type of content. Yeah, I can appreciate that not everybody will be available every time. So it will be, the replays will be available. Feel free to come back and look at them anytime you need. Hello, sir. I thought of starting the Python Data Science Handbook by Jake Vanderplas, but you are suggesting ISLP. Which one should I start? Isa says ISLP is a good start. It is beginner friendly. Ooh, I'm not sure if I'd agree that it's beginner friendly. To me, it's a book that is very hard to learn outside of the classroom. I mean, personally, I think I'm taking a big risk trying to teach the book. I mean, who am I to tell you how the book is? But what I'm trying to do is I'm trying to show you the real world side of it. And like I said, I'm going to be adding my own twists and turns. So, just hang around a little bit, Isa. I think your question will be answered, as we go along. Okay. AJ Patro says, is math a prerequisite to ISL? So AJ, I'm going to tell you no. And the authors will also tell you no. And I'm going to show that to you as we go along. Okay. So great question. And, I see a lot of familiar faces in here, so I know you guys have attended my streams before. So most of you know how I feel about math and data science. I think the requirements are overstated. And, I really don't agree with a lot of the data science influencers or other, every once in a while I'll catch little glimpses of other accounts. And I really don't agree with people who overemphasize the math. Personally, I think it's an intimidation tactic, gatekeeping, whatever you want to call it. Where people overstate it. But, I've been in the business for a long time in the real world, and I can tell you that you're mostly using libraries. So I like my staff, the data scientists who work for me, to have a good understanding of math, like a general understanding of what's happening, like, kind of underneath the code. But if you're writing native math and having to look up formulas and things, there's something wrong in your process. You've gone off track in your process if that's the case. And also, there's a lot of risk in writing your own math, right? I mean, having a math formula in front of you and implementing it properly in code are two completely different things, right? And sometimes those errors aren't obvious. Sometimes they're errors that you won't discover for years, and that's a massive problem, right? They can be very small errors. So I think you're going to be fine, AJ. Not you, AJ, but anybody in the chat or anybody listening who feels intimidated by the math and data science, I get it. It can be intimidating, but don't be. I'm going to make it as easy as possible on you. I'm going to give you kind of my own take on some of the math, okay? Kartik says, I even started ISLP by myself. You're brave. You're brave, Kartik, so good for you. Good for you. That's a bold statement, so good for you, my friend. Siddiqui says, I am very excited about these classes. I am too. This is fun. Like I've mentioned before, I will never, ever, ever, ever do pre-recorded instructional data science content. If you guys ever see me doing that, you can definitely say Dennis has lost his mind, because to me, it's boring to put together. I can't imagine anything that I want to do less than sit here and put together pre-recorded data science content. And two, I think it's boring for you guys. I personally don't sit through that content. I think it's boring. So why would I want to produce something that's boring for me and boring for you? So I do these live. I stream as often as possible. I'm going to be streaming quite a bit, for the next few months here. So hopefully you'll join me and keep on coming back. But yeah, I'm looking forward to these two just because this is fun and, lets me spend some time with all of you, okay? Llama Land says, this book is more math-oriented than the hands-on machine learning one. Not necessarily, my friend. Not necessarily. And I'm going to show you that. I'm going to show that to you, okay? So I'm not sure if I agree with you. I think the authors do a great job of explaining it without requiring it. Because they're ultimately, this book is still very code-based, and when it's code-based like that, they're still relying on libraries. So I disagree with it being more math-oriented. There's math in the book, but it's not something that's like required for you to do in the book. Like if you look at their exercises, right? None of their exercises in the whole book, their labs and all that, none of them require you to write your own math, right? So that's kind of the measure that I use. Video Game says, hi, Dennis. Hi, Video Games. Nice to see you. Thanks for joining us. Neiman Stravan says, this sounds exciting. Oh, well, thank you. I'm excited too. So thanks for saying that. Lamaland says, I'm mostly afraid of the SVM math. It is heavily emphasized on duality and Lagrange things. Yeah, okay. But how many times are you going to be using that in your career? I mean, you got to think about the practical side of it. I could think of 5 other things that you are much more likely to use than, SVMs, right? So don't worry. We're going to be just fine. We're going to, get through this step by step. I don't think we get to SVMs for a couple of chapters. I can't remember what chapter number it is. So it'll be a couple of weeks before we get there. And quite frankly, I'm just preparing the material as I go along. I've only prepared this week's material. I'll prepare next week starting like Thursday or whatever. Because, we're just going to take it step by step. And like I said, I'll be showing you some of the real world stuff I'll be emphasizing the real world stuff. Okay. All right. So that was a good introduction as far as the chat goes. So you guys ready to get started? I'm ready here. So I'm going to switch over to my classroom view. We're still going to have the chat. Yeah. So like I said, we still have the chat. You guys can still see me, and you're still going to see my desktop. My instructional desktop. Like I mentioned earlier, if you need to stop me for a question, please feel free to do that. I also believe in the Socratic method, so feel free to let me know. I'm going to be asking you questions, right? I'm going to be throwing out questions to the chat. So keep your speakers on, keep your headphones on. Feel free to participate as much as you'd like, okay? And there's no wrong answers, right? So nobody needs to feel like they're going to give a wrong answer, right? We're all learning. Amit says, hi, would you cover it application-wise and industry-wise? Maybe. I think the authors have something to say about that, right? So maybe, so I'll be pointing out some of those things. Okay, all right, guys, so let's get started. So I'm calling this the ISL book guided discussion because, again, my intent is to honor the authors, not copy their work. So my guide to you will be around the things that I find are important, or maybe I'll be expressing things in a different way than what the authors do, because I've seen it in the industry done in a slightly different ways, or just expressed in different ways. So that's really the goal here, right? To provide a guided discussion while still honoring the book and, honoring, really just the high level of instruction that's available in the book, okay? So today we're going to cover 3 sections. This is the first section. In this section, I'm going to give you a little bit of an introduction and my own philosophy. We're going to have a kickoff to explain how I see us working together, and then also a class agenda. All right. So the first part of my philosophy is that I take data science as a very serious profession. I equate doing data science like a lawyer or a doctor. It's an academic profession, but it's also a learned profession. You're going to learn things in. Sorry, let me get rid of this chat on my screen. You're going to learn things in the classroom, but you're also going to learn things on the job, right? If you're a lawyer learns a lot in school, but they don't learn how to always stand in front of a judge and be like a litigation attorney, right? That's like a whole other set of training they do after they graduate. So my intent here is to help you show you some of those combinations of the academic side and the real world side. And then you'll also understand that there is no shortcuts, no hacks to how we go about actually doing data science, right? We are not here to crack the data scientist interview or all those other things that you hear about. We are here to do, professional level work in data science. And then finally, a data scientist must maintain flexibility in thought, in their approach to problems, in how they see the world, how they see different models and the different business issues that are in front of them. So I'm going to try to put an emphasis on that for all of you here. Okay? All right, before I go to the next screen, quick question, guys. how does my audio sound? I just realized that I have my fan on above me, and I don't know if the microphone is picking up on the fan or not. What do you guys think? Is the audio coming through okay? Give me some feedback in the chat, please. Let me know how my audio is sounding, because otherwise I'm going to have to shut off the fan. Is everything sounding okay, guys? Okay, so Patrick says audio is great, no problem. Okay, thank you for that. All right, so next screen. As I said, I teach with the Socratic method, so I'm going to be asking you questions. So please, feel free to participate and let me know if you have any thoughts, or I'll be asking questions, getting feedback from you guys. So it helps the class go a little smoother that way. Also, you will not be ready for a job after this series, but I'm going to help you build a pretty good foundation. The ISL book, just to give you kind of the scope of things, the ISL book is typically just one course in a full master's study, right? So there's a lot more to learn, things that you want to kind of get deeper knowledge on from the ISL book. But I just kind of want to set that expectation for all of you that you should still be doing work on your own. You should be doing work beyond this book. Because again, our goal isn't just to land a job. Our goal is to dedicate ourselves to the profession of data science. That's kind of why I do these classes, because I want to build that professional mindset in data science. All right? All right, so thank you so much for the feedback in the chat. I'm seeing that the audio is good, so I'll keep it. Okay, so going to the next screen. All right, guys. So here's where it gets a little bit, more exciting, because this is kind of, where I'm adding my own secret sauce to the approach, right? So Introduction to Statistical Learning, ISL, has long been recognized as a book that gives you a really good foundation for professional level data science, right? I mean, this is not a quick tutorial or anything else. It's a very, dedicated book. It started off as ISL for R, which was known as ISLR. And then I think in the past 3-4 years, they've developed a Python version, which is known as ISLP, right? And we've already seen some questions in the chat about that, about, should I take this one? Should I take that one? Personally, I learned on the first or second edition of the ISLR book. So I actually took this course in R. And one of the things I've also recommended, if you look at my roadmap for students, I recommend that everyone start with the R version. And even if your favorite language is Python, as it should be, take the R version and convert the code to Python. If you do that, that's a very valuable exercise for your learning. Okay, so something for you to consider there, guys. Start with the R version, understand the concepts, and then do the labs, but in your own native Python code. Super valuable exercise. So we have R, we have Python. My addition, my addition, or rather my intent again, is that I want to build upon their work. I want to build upon their work and, honor the ISL authors, because it's intellectually dishonest to copy somebody else's work, right? So my addition is that I'm going to do this entire course using Gen AI. So this isn't going to be ISLR or ISLP. I'm naming this ISLA. This dovetails into some of the previous videos and some of the previous content that I've developed about what the future of data science is, because I truly believe that this is the future of data science, where we are going to be code editors, not code writers. So that is something that I'm calling the blank screen effect. So nobody in data science, and even in code development and software engineering, should start with a blank screen anymore. There's a lot of industries that shouldn't start with a blank screen anymore. right? If you're a lawyer, an accountant, a real estate agent, a software engineer, and you're starting with a blank screen, you're done, right? You're done. You shouldn't be doing that anymore. And we as data scientists shouldn't be doing that anymore. So we are going to write, we are calling this the ISLA course, and we are going to have these goals, right? We're going to be data scientists that are heavily aided by AI tools for development. We're going to learn the concepts from each chapter, but then we're going to take that understanding to become prompt engineers and prompt an AI tool. And then our goal will be to edit and refine the code to reach a deliverable state, but we're not going to be writing any code natively, or as little code as possible natively. Okay? So that's really kind of the twist that I'm adding to this, because I don't want to sit here and write code on a blank Visual Studio screen, because that's simply not the way that you're going to be doing it in the workforce. I think in as little as 2 to 3 years, maybe even faster than that, maybe 1 to 2 years, right? So that's really, it would be worthless for me to just kind of teach you the book that way. We're going to look at it strictly from an AI perspective. So we're going to sit here, we're going to learn the concepts, we're going to use ChatGPT, and we're going to work accordingly. Okay? So I hope that, that you find that exciting, because I really, I truly believe that this is the way of the future, right? A lot of, when you hear about people being threatened by their jobs or having their jobs threatened, this is why, because you'd be starting with a blank screen and you'd be writing things that Gen AI can do for you very quickly. So our goal here is to adapt with the times and start learning data science as a scientist that uses Gen AI tools to assist their work. All right? So how do you guys feel about that? Everybody still with me? Send me some feedback in the comments, but I'm going to keep on going here. So here's what I think about the agenda. So I'm going to be going chapter by chapter, and I'm going to give you guided instruction for the highlights of the ISLA book. But you should still feel free to do work on your own. And I'm going to be giving you little ideas for things that you could be doing on your own. That's how we're going to close every class, okay? I'm not going to cover every single section, but I'm going to give you the highlights. And then we're also going to do 1 to 2 exercises as a lab together. And then you can build upon those if you'd like. And then I'm also going to be working off the ISLR version 1 PDF. You are welcome to work from other versions, but that's the one that I like. That's the one I learned on. It's the one, I'm going to be using the PDF on the screen, but it's the one that I have the hard copy for. So whenever you see me holding a hard copy, this is the R version. I've had this book forever. It's so dirty. I hate even showing it because I've had it forever. But yeah, so that's the version I'm going to be using. So feel free to follow along with the same version, but it's up to you, how you want to go about them. There's a couple versions available on the website. Okay, good. I'm seeing some good feedback in the chat. People are on board with it. Explore the beauty. Good to see you again, my friend. Says this makes sense. Good. Patrick says ready to build some Gen AI skills along with my DS skills. That's the goal, Patrick, right? Because this is going to be the future, right? If you're sitting there with a blank screen, that doesn't make any sense. So yeah, very much looking forward to learn this mindset, since how many courses think about that. Llama, I like to think I'm the first person bringing. I think I'm certainly the first person bringing this book in that way, right? The ISLA approach, right? I don't think anybody else is doing that. I know there's other people doing, obviously Gen AI with data science, but we're going to learn together here. But I do think that we are breaking new ground in that regard. But again, this is the future. This is the future of data science. This is what you guys need to be learning if you want to, kind of advance forward. So Melly Dare says you can find the book on Z Library. You can find the book directly from the authors, because I researched this prior to starting, because I don't want to violate any copyright laws. I'm very big on respecting people's intellectual property. The authors themselves make it available. You can go to, thank you, Patrick. Patrick has put that in the chat. Yeah, statlearning.com. They freely make it available. Anybody can download it. I don't think it's always been that way. When I first got this book, I think you had to provide your email or something like that. But yeah, but now they just give it completely free. So Amit says, I'm here to revisit the ISLR book. It has been 6+ years since I haven't revised it. Yeah, that's a great idea, Amit. And maybe you'll pick up new ideas when you're looking at it from a Gen AI perspective, right? Because again, we're not going to be writing code. We're not going to be sitting here copying the code from the book. We're going to be using Gen AI tools. Joseph says, I like the idea of integrating Gen AI and DS as it will be the future. Yeah, great feedback, Joseph. Thank you for that. Glad to see you guys are on board with it. Again, I really think that this is the way all development is going. So I'm going to show you how I would go about it. All right. So let me see what else I have on the class agenda. So as I said, you are encouraged to get that PDF and get it prior to each stream session. My intent is to provide these classes every Sunday from now on. I make the announcements on Instagram, and I'll also I post some stuff in the community section of YouTube, but I'm not sure how many people will read that. But yeah, you're welcome to follow me on Instagram. Feel free to subscribe here on YouTube so you get those alerts. And the live streams will be hosted here on YouTube, as I mentioned earlier. All right, so these are the topics that I intend to cover. Or rather, this is what's covered in the book. General concepts is what I'm calling chapters 1 and 2. And then chapter 3 focuses on linear regression. And then you can see the different sections that are covered in each chapter. And after today, it's my intent to do one chapter every week. So some sessions will be shorter than others. But this is the schedule that I intend to keep following along with these chapters. So somebody mentioned SVM. Yeah, so SVM, we're not even going to get till chapter 9, which will be the second to last week. So that's 7 weeks from now. So if you're intimidated with the SVM math, that's okay. We're not going to be there for a while, okay? And yeah, okay, so before I go to the next screen, Melly Durr says, what is Gen AI, please? Okay, so Gen AI, we are referring to generative artificial intelligence tools. My focus will be on ChatGPT. You are welcome to use another tool. But basically, we're going to be asking AI to write the code for us. So that's what we're talking about when we're referring to Gen AI. So the ISLA that I'm proposing, the A stands for artificial intelligence, okay? Maybe it should be ISLAI. You give me some feedback on that, guys. I kind of like the ISLA, but you guys let me know if it should be ISLAI. Giovanni says this is going to be great as I am to start iMaths in data science. Well, great, Giovanni. Good to see you here. Isa says Gen AI is generative AI like ChatGPT. Thank you so much for the assist in the chat, guys. I don't always see the assists ahead of time, but thank you so much for jumping in there, guys, and helping each other out. That's wonderful. I love seeing that. AJ says, so it will be AI code and our job will be refactoring and debugging. Absolutely, AJ. That's a great way of putting it. So it's not just going to be about refactoring, though. I call it, you're going to have to be a data science architect or a software engineering architect, right? Because you're going to have to kind of see all the different pieces that you need in your code. So as a data scientist, you might say, okay, well, I need some code to do my training. I need some code to do my cross-validation. I need some code to do my runtime predictions. Let me make those separate classes. So I need 3 separate classes, and they need to talk to each other this way, and they're going to talk back and forth using this data approach. So you are still going to be adding all that design, that architecture level design, and then asking ChatGPT to write that, right? We're not going to see a lot of that today, but in the future we are going to see that, where you are going to be more like, okay, it's not just ChatGPT, give me code. You still have to guide it and say, well, I need this object, and then I need this object to look like this because it needs to talk to this other object, and then I need the code to consume those objects, right? So you're not far off the mark, but it's definitely going to be more than just refactoring and debugging. You're going to have more of a design mindset to say, oh, okay, yeah, this is like my business stakeholders approach me with this problem, but this is how I see it in my mind. I need these objects, I need this data, I need to pull it from this source. So that's what you're going to be doing more of, okay, AJ? If I lost you in a couple of those terms, that's okay. It's gonna make more sense as we go along in these coming weeks. Kartik says, is there any community or on any platform you guys are on? Kartik, not yet, but I am going to be launching a Discord soon. I have a Discord ready to go now. I just wasn't sure if people were interested in it. But yeah, I'm gonna be sending out something on that soon. Okay, so bear with me on that. Ashish votes for ISL AI. Rahul votes for ISL-AI. Okay, I'm kind of liking both of those. Isa upvotes ISL-AI. I like ISL-AI. So Explore the Beauty is the only one that's with me on ISLA. I kind of like ISLA, but you know, there's clearly ISL AI sounds better, directs it to the uses and intended for this series. Okay. Or Joseph puts the I in lowercase. I'm wondering if that's intentional. I think it is, Joseph. But yeah. Sravan says, sorry to ask, but how can we reach out for any questions or doubt? Right here, Sravan, you're in the right place. So feel free to put them in the chat. I will try to address the chat. As you can see here, I do try to pause and address the chat. Or if something is not clear, feel free to put something in the chat. If I miss a question, you know, I'm gonna do my best to scroll up, or maybe Patrick can remind me if I missed a question. But you're in the right place to do that. And like I said, I might start a Discord to help all of us kind of stay in contact throughout the week. But we'll see. Okay. All right. So let me go to the last screen in the intro here. So I want to emphasize something with you that, you know, if you were to take classes from an Olympic athlete who throws the javelin, right, as an example, they're going to show you like the highlights, like the main like factors in how to do things, right? They're going to tell you like, oh, you know, you need to hold your arm this way, you need to run this way, and then you throw it at this point. You know, they're going to give you like the high level pointers, right? But you might have questions like, you know, well, why does my wrist have to be this way? Like, how do I know where to put my wrist, you know, on the actual thing? And that athlete is going to look at you and they're going to say, I don't know, I've just always done it that way. I've been doing it for the last 15 years. I don't even think about it anymore, right? So I'm telling you that I feel that way also, where there's going to be things that I just, you know, I've been a data scientist and a software engineer for a long time. So there may be times when I'm going to say something that is just normal to me, but maybe you guys don't understand it, you know, or somebody who is new to the industry wouldn't understand it. So feel free to stop me and let me know when you need more detail. But there might be times when I'll tell you, I don't know, I just always done it that way. I just, you know, just the way we do things, right? So if that happens, you know, I'm kind of just setting that expectation with you guys, because it may very well happen. But you know, just keep in mind that, you know, I may just gloss over things, not because I'm trying to, you know, be fast or anything, just because I haven't thought about it in so long. So bear with me on that, okay? All right, so let's get into section 2. So in section 2, and by the way, this is the second of 3 sections we're going to cover today, right? So in section 2, I have basically condensed chapters 1 and 2, and then maybe we can talk about some self-study that you can do based on chapters 1 and 2. And it sounds like some of you have already read chapters 1 and 2. So that's good, okay? All right, so again, I'm going to be trying to break things down for you in a simple way, in a real world way. So one of my biggest takeaways from chapter 1 is that what exactly does it mean, introduction to statistical learning? Like, it doesn't really like ring a bell in terms of like general topics or professions, right? So the authors establish that introduction to statistical learning is essentially data science. I think that they were maybe locked into the title because of the previous works that they had done. I think, what was their first work? I think it was Elements of Statistical Learning or something like that, ESLP. But this is basically a data science book. So I want to establish it to you from the beginning that when you hear ISL or the ISL book, you should be thinking data science, because this is essentially a data science course and it's a data science book. Personally, I took this course as part of a applied statistics master's study, because that's what my master's studies were in. I did it a long time ago, so data science degrees weren't even available then. And maybe you live in a state or a country where none of the universities that you're considering have a data science course. So applied statistics might be the closest you can get, and this book or this type of course would be part of that. But let's establish from the beginning that statistical learning is a synonym to data science. Okay? The next thing that they emphasize, or that we think about when we think about data science, is we think about the different types of outputs. And the authors emphasize that there are quantitative outputs, there are qualitative outputs, and there are clustering outputs. Right? Those are basically like the three things that data science can do. Okay, guys, so this is me using the Socratic method. In the chat, feel free to pick one of these and give me your 10-second elevator pitch on what's one of these outputs. What is a quantitative output? What is a qualitative? What is clustering? You don't have to do all three. Just pick one. Hopefully you guys will pick different ones. What do you guys think? Somebody give me an example of these outputs. So I'm going to give the chat a couple of seconds here. But drop me in the chat. What do you guys think? What are we talking about when we mean quantitative or qualitative or clustering? Give me your 10-second elevator pitch. Don't be shy. Put it in the chat, guys. All right, Joseph says a quantitative output is one that yields a numerical value. All right, anybody else? I'm not going to give my answer right away, right? Because I don't want to bias you guys. Quantitative output is measurable. Okay, cool. Quantitative output is something we can count. All right. What about qualitative? Anybody want to take on qualitative or clustering? Quantitative output is like an output of a regression problem. Clustering is trying to find out a correlation among available data. Okay, Seed None, welcome to the chat. Thank you for volunteering for clustering. Qualitative says insight about data, maybe. Ooh, Ashish, but isn't everything we're doing insight about data? Give me a little bit more. I think you're on the right track, but give me a little bit more. But insight about data is everything. Is all data science, right? The three are all under supervised machine learning tasks from an ML perspective. Okay. Now remember, guys, this is all in chapter 1, right? So they haven't even proposed any models at this point. They're just talking in chapter 1, right? They're just kind of laying it out for you. So don't be tied to, oh, this is regression, or this has to be this, right? They're just talking in generalities here. So don't necessarily tie it to a model yet, right? Patrick says a qualitative output is a rejection of a hypothesis. Okay. Isa says regression is quantitative. Muhammad says clustering. Muhammad, welcome to the chat. I don't think I've seen you before, but welcome. Clustering, grouping according to similarities. All right. Melly Dare says qualitative is like colors, etc. We can't count it. Ooh, Melly coming in strong with the unique description. Nice. You know what? I'm not hating that description, Melly. Good job. It's a unique description, but I'm not hating it. I think I'm with you. Okay, Kartik says qualitative is classification. Trap Bushali, Trap, welcome. I don't think I've seen you in the chat, so thank you so much for joining us. Qualitative is sentiment analysis. Okay. Give me a little bit more on that. You're not wrong. I like that you tied it to an example, like a programming example, but give me a little bit more. Why would you use it for sentiment analysis? 8G-Man says quantitative would be something like the average of a sample. Qualitative is the average of a sample A is bigger or smaller than sample B. Clustering would probably be seeing trends within a data set. Okay. Amit says clustering is something where things can be grouped on the basis of some common quantitative, qualitative parameters. All right. What else we got? Quantitative outputs is like prediction of value, like house price. Okay. Qualitative is an output that helps use descriptors, words, pictures that help understand the nature of the data or observation. Yeah. Okay, Joseph, I like the way you put that. Oh, by the way, guys, no using ChatGPT. I forgot to mention that because Joseph, you wrote a beautifully written answer, so it's almost too suspicious. But I'm going to give you credit for that. But no using ChatGPT, guys. All right, that's not quite the purpose of the exercise. Clustering is kind of sorting things like fruits. Okay. Quantitative is a numerical way to represent the output. I like the way you put that, AJ. No name. Welcome to the chat. I haven't seen you here before, so welcome. Quantitative is about finding insights or numeric forms about data, about relationships between two or more features of the world. Data about between two or more features of the world. Qualitative is about intrinsic, contextual information. No name. I'm generally on board with your answer, but help me understand why it has to be two or more features of the world. Give me a little more information on that. What do you mean by that? Joseph says, promise it wasn't ChatGPT. Took a while to phrase it. Well, it was very well phrased, Joseph, so I appreciate that you took the time to do that. Good job, my friend. Qualitative has a spectrum. Okay. All right, these are all great answers, guys. Great answers. Some really, quality answers here in the chat. So my intent is not to signal out any one person because I don't want anybody to feel, bad about their answer. But you guys are definitely on the right track. So quantitative is definitely, I think most people got quantitative correctly, where it's some sort of a measurable output. Somebody mentioned house prices. That's definitely a quantitative output. There's tons of quantitative outputs. But basically, quantitative outputs is when you can put a numerical value on it. Qualitative output, somebody in the chat accurately described it as being like a classification problem. And that is 100% correct. You are typically saying, I can take in numerical inputs, but I want to give it a classification for some sort of a description. Or, somebody else also said about how it helps you to put it into plain English words. And that is a very good way to put it. Because classifications, those qualitative outputs, can be anything you want. You can name them whatever you want. You can have as many as you want, right? So that's what you want to take away from qualitative outputs. That it's basically different categories that you can have, and you can have 2 categories, 4 categories, whatever you want. It doesn't matter. Okay? And then for clustering, I want to find, somebody did it perfectly. Yeah, here we go. So Amit, I think you gave a great answer on this. Clustering is something where things can be grouped on the basis of some common quantitative, qualitative parameters. That's a great answer. That's a really good way of looking at clustering. Basically, you can say, I have these different items, and I'm going to group them by the different attributes that they have. Those are going to make my clusters based on the values of the attributes. And those attributes can be qualitative or quantitative. And I'm going to put them in these clusters. And then that way, and the reason you would want to do that is because then that becomes your model, right? For future predictions, you can say, when something has these attributes, go ahead and put it in this cluster, right? To get a little fancier with it, you can also figure out the clusters on a plane, and then you can figure out how related clusters are to each other, or how different items are related to that individual cluster, right? So that's why you would want to do that. So I think you guys did great in that. So a couple of things that I do want to point out, though, is that you shouldn't be thinking about them as supervised or unsupervised at this stage just yet, especially when it comes to clustering, because there are clustering approaches where it doesn't have to be supervised data. You can use clustering for unsupervised data. If you don't know what supervised and unsupervised is, don't worry. We're going to cover it very shortly. But remember, guys, this is just page 1, chapter 1, right? So it's too early to start kind of thinking ahead in terms of, oh, well, it has to be supervised, it has to be unsupervised, it has to be this type of model, it has to be this type of data, it has to be a regression problem. Let's just accept this for what it is, right? We just have to understand what the different outputs are that are possible from models, right? And also, I think the authors lay this out because it's very difficult to come up with other problems or some business problem that you're going to face that don't fit one of these three items, right? There's usually some way that you can tie back all your future work, all your future models to one of these three, okay? All right, Patrick is giving a shout out to Joseph for his description. So yeah, you know, I love the fact that you guys are encouraging and helping each other in the chat. Keep that going, guys. All right, so let's go on to the next slide. Another thing that I really liked in chapter 1 is that the authors lay out these 4 premises. Or premises is my word. I don't think they call it that. But they kind of lay out these 4 different thoughts for you to work with. The first one is that the approaches in the book are the most widely applicable across industries. And I completely agree. So somebody earlier when we were doing our intros asked about that, about, you know, can you relate it to the work environment, to industries? Well, the authors are already telling you, hey, this is what you need in most industries. We have intentionally picked these models because we think that these are the most applicable for you when you are in the real world. So that's why I didn't answer that question directly previously, because I knew I was coming to this. And the authors are basically telling you, hey, we chose these on purpose. We've seen these in industry and we think these are the most applicable. So keep that in mind as you go through the book. And just, you know, kind of, you're in good hands in terms of saying, hey, these are the ones that you should be studying because you're going to be able to find applicability in the future. All right. Second item that they also emphasize is that no single approach is going to work in every single model, every single problem you come across. You're going to have trade-offs where one model would be good and maybe not so good. And the words you see in brackets there, and experiments conducted, is my addition. Because the authors don't really say that, but this is what they're implying here. Where you should never say, well, let me take that back. You know, there's that old saying that when you have a hammer, everything looks like a nail, right? So you're going to be tempted to say, oh, I learned regression models today, so the next problem you come across, you're going to try to apply regression to it, right? But that's not the right approach. That's not a scientific approach, because the scientific approach is to conduct experiments and to try different models, right? You know, you have these in the real world, you're going to have these champion model searches where you have a problem and then you try different approaches. Let me try a regression against it. Let me try gradient boosting against it. Let me try a neural network against it, right? So that's what the authors are trying to get across here, that you shouldn't get married or feel like only one model is going to work. You should be approaching it with an open mind and trying different models and conducting those experiments. And again, experiments is my addition. They don't say that, but that's really what they're describing. I mean, that's what we do. That's what I do with my teams. When I lead teams, you know, we conduct experiments. That's the science part of data science, right? So that's the second part that I think we should pull away from chapter 1. The third thing, I'm going to read this verbatim. I don't like reading slides, but I think this one is worth reading. We assume that the reader is comfortable with basic mathematical concepts, but we do not assume a graduate degree in mathematical sciences. And they go on to explain a little bit in that section, in that paragraph. And this comes back to the previous discussion we had. Somebody asked about the math, and they were intimidated by the math. The authors themselves are telling you that you do not need a lot of math. And I agree with this. I have seen this in industry. I have led many teams throughout the years. I've hired dozens of data scientists and run hundreds, if not thousands of team meetings. And we've never once sat there and discussed math formulas back and forth. That's just not how data science is done in the real world. I'm going to show you a couple formulas to get you, off the ground, kind of understand the inner workings. but you don't need, this deep understanding of math. Okay. And again, it's not just me saying it, it's the authors. The authors are saying this. I copied this directly from the book. And I did that because I know that a lot of you have approached me in the past about the math and, oh, maybe I'm not so good at it, or, maybe I shouldn't take this course because of. Don't be intimidated. Okay? You're going to be just fine. You need to have an understanding, but it's nowhere near as deep as some of these other books or other things you see on social media or whatever emphasize. To be frankly honest with you, when I see the videos or the postings where people overemphasize the math, that person has told me that they have zero real world experience. They're basically faking it. They have never had a data science job in their lives, because that's just not how it's done when you're out there in the real world. Okay? And then the last thing that the authors give in these 4 premises is that the book focuses on real world problems. And they give you a lot of real world data sets to work from. I'm not sure if we're going to be using the same data sets that they emphasize, but they do say that, hey, we've tried to make this as realistic as possible, and they've done a pretty good job of it. So, take those 4 premises as you'd like, but I think they're really important. That's why I pulled them out to highlight here, because I got a lot out of these premises, and I agree with them. I like their approach. So that's I think those are important for you to read. So make sure you catch those in your edition of the book. Okay, you guys with me? I think we're making good progress here. So give me some feedback in the chat. Let me know that you guys are doing well. But I'm going to move on to chapter 2 while I'm waiting for that feedback. And you know what? Here's another opportunity for you guys to participate. So chapter 2, they start off. Well, I don't think they start off. This is just what I pulled out. They start off. They wrote about predictions and inferences. Okay, so there are 2 things in data science also. And really, some of these are kind of like statistics oriented. Predictions and inferences. Who wants to kind of give a challenge, or take a shot at giving me definitions for each of these? You guys did great earlier, right? So feel free to do it again. Really short descriptions, and I'll even give you guys a hint. Because in my interviews, I give a question. One of my interview questions is, what is inferential statistics? And can you give me an example of inferential statistics? That is one of the questions I ask in my interviews. So I think this is really important. That's really why I pulled this out. So great. AG Man says, let's keep moving forward. Wonderful. Thank you for that feedback. All right, guys. So I'll give you guys a minute here to feel free to, add your feedback. But tell me, what is a prediction, or what are predictions, and what are inferences? In some cases, some people might say that they're the same. Are they? I don't know. But I'll give you guys a minute here. Tell me, what are predictions and what are inferences? So give you guys a little bit to think about it. So Kartik says prediction is when is based on one variable or more. We try to predict another variable. Okay. Okay, Kartik. So now give me inferences. I'm going to take a little sip of water here. I came prepared, guys. Last time we were here for 2 hours. We might do the same. We might do longer. But I'm prepared. I got my water. I had a big breakfast. I'm prepared to be here as long as this takes. All right, so Kartik has volunteered his answer. Nobody else wants to participate? Melly Dare says prediction is to give the result without being sure about it. Okay. But Melly, isn't all of data science like that? Data science is really a kind of making educated guesses, right? Remember, guys, and we've talked about this before, data science does not give you the answer. It gives you the most probable answer, right? Never forget that. I want you guys to burn that into your brains. Very important to remember that. So, Melly, I'm on board with your answer. I think you're on the right track. But we're always unsure about our results in data science, right? So let me know if you want to expand on your answer, okay? Okay, Patrick says inferential statistics refers to calculating statistics from the data, like mean, standard predictions are new data points that are statistically consistent with our data. Okay. Okay. So Melly adds inferences is to give the results based on what we see. All right. I can be a little bit on board with that, Melly. Feel free to expand on that if you want. 8G-Man says inference is what you conclude from your analysis. A prediction is what you expect to happen in a foreign data set based on inferences you made from other data sets. All right. All right, AG-Man. I think you've provided the best answer so far. I'm on board with that answer. Prediction is making a guess based on unseen data. Okay. I would refer inferential statistics to measurements of correlation or causation between two or more variables. Oh, no name. Good answer. Good answer. We're going to come back to your answer, my friend. I like the answer. Sravan says predictions talk about future and inference may be talking about why. Ooh, Sravan, I like it. I like it. I like it a lot. Wow, Isa, you guys are doing great. You're refining the answer with every message because Isa writes, inference is based on the relationship of the variables. Love it. Love it. Great answer, Isa. Okay, guys. So, as a group, as collective answers, I think we've gotten there, right? I love different elements of these different answers, right? Okay, so Kartik, we're going to go back to his answer. Prediction is based on one variable or more, and we try to predict another variable. Yeah, that's exactly it, right? We're taking what we know, and we're trying to make predictions on the future, on what can happen on unseen data, right? Somebody else wrote about unseen data. So that's a pretty good example of predictions, right? In other words, you could also say if X happens, what is gonna be the result of result Y, right? We know that X happened. What is result Y? You're making that prediction, right? And then inferences, no name, Sravan, and Isa, I think collectively provided a great answer. And, Isa basically sums it up, where inference is about the relationship between X and Y. In other words, what is the impact or I guess that's the best word for it. The impact. If we know that X has changed, what is the impact on Y? Right? Just because X changed by a value of 1 doesn't mean that Y will change with a value of 1. There could be like an exponential relationship there, right? Where X changes by 1, but Y changes by 2. So that's where the difference lies. Where prediction says X happened, what is Y going to be? Inference is X is this, but now it changed. X increased by 1 or decreased or whatever you want to do. What's going to be the effect on Y? So that's what you kind of want to do when you want to think about these, where what's going to happen in the future, and then what's going to happen because something else already happened. I also want to highlight 8G-Man's answer because that was a really good answer about what you expect to happen based on the inferences you made from the other data set, because inferences can also be used for predictions, right? So I think you guys are doing great in those answers, but I want you to keep that in mind, that there can be two types of conclusions that you're coming to, okay? Let me look at some of the other chats. Yeah, Muhammad, that's a pretty good answer. Predictions are the results of new incidents based on past experiences, yeah. Inference is providing evidence to your hypothesis on the basis of parameters. Yeah, that's a good one. Joseph, yep, I'm on board with your answer. Seed none, did you just describe classification versus regression? No, I did not. So seed none, like I mentioned earlier, right? We're still in chapter 2, okay? This is I think page 10 of the entire book. So don't jump too far ahead on me. Don't think about models. Don't think about, business problems or anything else. Just take in the data, right? Because all we're doing is establishing the foundation for what's possible within statistical learning, within data science, right? That's all we're doing right now. So I love that you're participating, but let's try, all of us, to not get ahead of ourselves, because it's easy to kind of get drawn in by the modeling and everything else. We're just talking here. We're just talking. Establishing a foundation, right? So inference is correlation of two variables. It can be, yeah. You can use inference for a correlation, sure, because it will tell you a little bit about the relationship between the two. It will also tell you if there's a relationship at all, right? The inferences don't have to exist. Sometimes they do, sometimes they don't. But yeah, Kartik, that's if you want to think about it in those terms, yeah, I'm on board with that. All right, let's go on to the next section. So this is one of the charts that the authors put together, and it's a chart where they ask you to think about interpretability versus flexibility, and they're giving you an idea of some of the different models that you could be using along the way, and as far as how they grade on these two scales. Sometimes these will be important, other times they won't. Interpretability is a big topic when you get to the business world. Some models require a very high some problems that you have that you're going to come across in the business world require a lot of interpretability, others don't. So that's going to affect your model selection. So as an example for that, the example I always give to my teams is that if you're working for like a bank, like let's say you're working for like a credit card company, and you use a model to help you determine whether you give somebody a credit card or not, right? Like a credit scoring model. In the US, it's illegal for you to deny somebody without giving them an explanation of why. You can't deny somebody and not tell them why. Maybe that applies in your country, maybe it doesn't. But that's a place where you need a model with high interpretability. You can't just say no. You have to say no, and this is why. So now your selection of models has decreased a little bit, right? Because now you are required to use a model that has interpretability. Are all problems like that? No. Some problems you don't care why. You just want the better answer, right? So you keep this in mind. That's why this chart jumped out at me, because that's one of those real world things where you're only on chapter 2, so you're thinking to yourself, well, why do I need to know about interpretability, right? Well, that's why, because in the real world, that's going to be a big topic, whether something needs to be interpretable or not. All right, guys. So next chart. There, again, we're talking basics here. Supervised learning and unsupervised learning. Somebody brought this up earlier. But yeah, so now is the time to think about this. Give me some definitions for supervised learning and unsupervised learning. And again, this is a question that I ask in interviews. In fact, it's usually my first question. I love kicking off interviews with this question. My question is, what is unsupervised learning and what is supervised learning? And give me a real world example of each. So you guys are welcome to answer either one of these, or give me an answer to the interview question. But you're going to come across this in interviews, guaranteed, right? So go ahead, chat. I'll give you guys a minute here. Let me know, what is supervised learning and what is unsupervised learning? Give you guys a second here. I'm going to take a short little camera break so I can adjust a couple things on my end. All right. Okay, so Kartik, I love your speed. You're always fast with the answers. Love it. Supervised learning is when you have a label, and unsupervised learning when you don't have a label in your data. Okay. Any other answers? And Kartik, if you want to go for the interview question, let me know. Give me a real world example of each one of those. Melly Durr says supervised is having the answer and the questions, and we want to teach the robot how to find the answers. Yeah. I like it, Melly. Anybody else? Supervised learning. Isa says supervised learning, the model knows where the output will be, while unsupervised has none. Okay, I'm on board with that. Supervised learning requires labeled data, while unsupervised doesn't. An example of supervised learning will be having data on which every sample has an etiquette attached. Unsupervised will miss the etiquette. Okay, Seed None, I'm on board with that answer. She says we have the input as well as the true output while training the data for supervised learning. I like it. Supervised learning is training model based on labeled data, which is telling the machine to learn the problem with answers. Yeah, I'm on board with that, Llama. Supervised learning is when we wish to predict y from x and you know what y is. Unsupervised learning is when we wish to model underlying structure of x. Patrick, I'm on board with that. Thank you. Unsupervised, I think Sravan is providing an example here. Find patterns segmenting customers on purchasing behavior. Yeah, perfect example. I would definitely accept that example in an interview. So good example there, Sravan. Dragomir says supervised means that we already give the answers to the model and it learns based on those. Yep. Supervised is we have just the questions and the robot has to find the results by itself. Yep. I like that, Melly. She says supervised learning example, predict height for a given age. Yep. Yep. In fact, I think that's in their book or in somebody else's book. Explore the Beauty says supervised learning is concerned with training a model of labeled data and using it to make predictions based on unseen data. Yep. Okay, good. Lots of really good answers here. Yeah, Muhammad, I'm on board with that answer. Joseph, also on board. Okay, so you guys seem to have a pretty good view on supervised versus unsupervised. Siddiqui Diaby, welcome to the chat. I don't think I've seen you before, but welcome. Supervised learning is when there is pattern in the data and the machine learns from that. Okay. Joseph says unsupervised learning is like exploring a new city without a map. The model looks for patterns or groups in data on its own without knowing the right answer before. Yeah. That's a good answer. All right, so you guys are coming up with some great answers for unsupervised and supervised, so thank you so much for that. So let me ask you this as a follow-up. Can unsupervised learning become supervised learning? Can do these kind of cross over? Can you have unsupervised learning that becomes supervised learning? Because you guys have a pretty good idea of what each one is. I think everybody basically gave a good answer. But what about crossing over? What do you guys think about that? Let me know. Give you a couple seconds to think about that. Can unsupervised learning become supervised learning? And if so, how? Or if not, why? Okay, Seed None says yes. Okay. How? Okay, yeah, perfect. So Servan hit it exactly on the head. Yes, because we can label data. And that's exactly right. That's exactly the answer. You can turn an unsupervised problem into a supervised problem. You could take the time to label your unsupervised data. And I bring that up because that is dealing more with your stakeholders, right? How you manage your stakeholders. Stakeholders are going to be critical for you to be working with because ultimately they're the ones that you're serving with your algorithms. Like you're trying to solve their problems, right? So sometimes you won't be able to find a valid unsupervised approach to a problem and you're going to need supervised data. You're going to need labeled data. So these are the interactions and quite frankly, the negotiations that you're going to have with your stakeholders in the future to say, hey, we're a data science team, but we don't know your data. You guys know your data. So can you label 5,000 records for us to help us in this effort? And that's like a whole other process, right? Stakeholder management is like a whole other thing you have to master as a data scientist. And I have some resources that I'm going to be releasing to help you guys with that. But that's why I asked that question. because you should note that you can get to labeled data, but it's not always easy. It's not always a straightforward path, okay? So that's why I wanted to bring that up so you guys can kind of, keep that in the back of your mind. But you can turn unsupervised data to an unsupervised problem into a supervised problem, but it's usually going to require the help from the business. All right? Okay, guys. So I love the feedback. You guys are giving me some really good stuff. So let's keep going. Love the progress we're making, guys. Okay. Scalar outputs and categorical outputs. What are these? Hint, hint. We talked about these earlier. What do you guys think? Scalar outputs and categorical outputs. What are they? And on the previous question, Kartik says, not perfectly because there will be wrong label in data during unsupervised. Absolutely, you're correct. But again, that comes back to the whole, the item that I said earlier. It's going to require a negotiation on your stakeholders. Because labeling data is not fun. It's not fun for you, it's not fun for them, right? So you're going to have this back and forth with the stakeholder manager. And you're right, Kartik, there could be errors, right? The labeling has to be quality labeling still, right? And there's ways to do that, right? I recommend you have to have a minimum of 3 people. The 3 people work independent from each other, and on the back end, you're doing like a polling on the answers, so on and so forth. But talking a stakeholder into doing that is like a whole other discussion, right? But Kartik, I just wanted to highlight your message because you're on the right track. Just because it's labeled doesn't mean it's right. So I love that thought there. So thank you so much for that. Okay. Yeah. So I'm seeing Patrick and Joseph. They're hitting it right on the head. And this is exactly why I picked this particular portion out of the book, guys, because I think that the authors here could have done just a little bit of a better job tying those back. But I'm presenting it here just to show you guys to not be intimidated, because you're learning all these terms, but the terms they're correlated, right? They're correlated in a funny way. So yeah, both Patrick and Joseph have great answers up on the screen in the chat. Scalar is your qualitative outputs, right? Categorical is your quantitative. Wait, I'm sorry, I got that backwards. Sorry, I got that backward. Scalar is qualitative, categorical is quantitative, right? That's it. So yeah, actually no, I think I had it right the first time. Yeah, quantitative is scalar, category is qualitative. Sorry, folks. I have a lot happening on my screens. I need to do like a behind the scenes so you guys can see what my screens are like. So I'm sorry that I'm a little loopy. But yes, you guys are coming up with the right answer. But again, the whole purpose here is just to show you guys that, don't get intimidated. There's a lot of new stuff coming at you, a lot of new terms, but a lot of the stuff is correlated. So when you hear about scalar and categorical, just think the qualitative and quantitative. In essence, we've already covered this, right? So that's why I pulled this out, because just kind of, take it easy, right? Don't be hard on yourself. Don't beat yourself up. It's a new topic, but they're all correlated, all right? So I hope that makes sense on why I wanted to bring that out. Okay, so now, I think this is the end of chapter 2, yeah. So to close out chapter 2, the authors get a little bit closer to inching forward to modeling, right? Because this is really, because remember, everything we've talked about before is just setting the stage, right? And in chapter 2, they close it out by talking about like your model accuracy. And again, I'm copying directly from the book because I think this is an important quote. No one method dominates all others over all possible data sets. So this is where I want you to start thinking about the experimentation mindset that you need to have as a data scientist. Because you should be trying different models on any problem that you come across. You might look at a problem and say, okay, that's supervised, or that's a supervised problem, that's an unsupervised problem. But that's really as far as you want to go in terms of your assessment. After that, you should be saying, well, I'm open to whatever model can solve this, so I'm going to try 5 models, 7 models, 10 models, whatever the case may be. But keep in mind, again, this is from the authors, no one method dominates all others over all possible data sets. Very important. You should be carrying that forward through everything you do in your entire career. All right. And by the way, guys, if you see me looking up here, it's because I have my classroom monitor up above. I bought this whole monitor stand and everything, so I've got multiple monitors here. But that's where I'm looking if you see me looking up over here. And then they also include their first measurement for model accuracy, and that's the mean square error, or the MSE. It's commonly used for regression problems, and it's measuring the difference between predicted and actual responses. What does your training data say that the responses should be versus what does your model say the answer should be? What is the mean difference between those, or between the errors that those two models make, right? So this is kind of how, again, they close the chapter 2 with these, because they're inching closer and closer to saying, hey, let's get into our first modeling. So I kind of want to, just kind of set the stage there, because I think it's a really nice segue, because now we're going to be talking about linear regression, okay? All right, so you guys with me? Anything on this last screen? Because our next screen, we're going to be talking about modeling. So everybody good here? I think we should be good. But give me some feedback. Are you guys doing well? We've been going for over an hour, guys, so thank you so much for sticking in there with me. I see a couple names that have been with me since the very start of this stream, so thanks so much, guys. All right, any other questions before we leave chapters 1 and 2? This is a great time for it, guys. All right, Patrick says going strong. Good, glad to hear it, Patrick. Melly says yes, loving it. Okay, so Isa, you're asking a good question. I'm gonna come back to this, okay? If I forget it, let me know, but I'm gonna come back to this. You're asking an important question. All right, good. So I'm getting good feedback from you guys. All right, guys. So let's keep going. Give me just a second here to switch out one of my screens. All right, so chapter 3. So chapter 3 is our first modeling effort, and they start off with linear regression. And I think that's great. I think linear regression is a very good model to learn the basics of data science. So we're going to go through the chapter notes. I'm going to give you a framework that you would use going forward. We're going to do some labs, and then I'm going to recommend some self-study that you guys can pick up, okay? So, all right, guys, this is our first bit of math. Nobody panic. It's just some math. All right, so in the chat, what formula am I showing here? Now, you can think about it in the math perspective or just like a general perspective. It's not necessarily a data science question, but what is the formula that I'm showing here? Give you guys a minute here to think about it. What's the formula? What's the name for this? All right, cool. Patrick, Muhammad, I'm already seeing great answers. Joseph, yep. You guys got it. It's a line, right? It's a formula for a line. That's all it is. That's all regression is, right? And Muhammad, yeah, it's rise versus run, as Muhammad talks about the slope, right? It's rise times run. That's all we're doing. And really, that's kind of like what I want you guys to just take away, that you shouldn't be thinking about this as complex approaches. It's just lines, right? Angel Torero, welcome to the chat. I don't think I've seen you before, so welcome. But yeah, it's just a slope. It's a slope, as Ashish points out, with no intercept. So I just want you guys, everybody, just to calm down. All we're doing is just filling out this formula as our first data science effort, right? Y equals m times x. That's it. I think it was Patrick that mentioned mentioned the origin, right? Which this does go through the origin. Not everyone will, so we'll introduce that in the next slide. But yeah, but all we're doing is doing a line, right? So I want to make sure everybody kind of just relaxes. It's not complex math here, guys. Fernanda Vallejos. Fernanda, welcome. I don't think I've seen you in the chat. Thank you for joining us. Equation of a line, I think, is a translation. I think that's Portuguese. But yeah, that's exactly right. Okay. Amit talks about a Python, I guess a repository. Amit, I'm not a big fan of GitHub. If I release this stuff, I might release it on Discord. And I'll just put the files up there. But as far as GitHub goes, remember, we're not writing code, right? We're writing prompts. So I'd much rather just post the prompt file than anything else, right? So maybe you missed that part, but yeah, maybe some people join late, and that's okay. We're not going to be doing blank code screens here, guys. Okay? We're going to be utilizing Gen AI in a very heavy way to help us write our code, because that's really my own twist of what I'm adding to this process. This isn't ISLR, ISLP, this is ISL AI, because we're going to be using AI to help us with that, okay? But really glad to see all the people that are joining us. I'm seeing a lot of new names, so thank you so much for joining us. Thank you. Even if you're joining late, thank you so much for that. I mean, we're almost going for an hour and a half here, so like I said earlier, maybe you need to step away. That's okay. Come on back. We might still be going. We might still be going 2 hours from now. Who knows, right? But thank you so much for joining us, guys. All right, next slide. This is an illustration of what we're doing, right? This is all we're doing, guys. And again, I'm putting these out there so that you guys can understand that it's not really intimidating. Data science really can be this simple. So what do we have here? We have our two axes. This is straight from the book, guys, right? Section 3. They usually label the charts. They don't have it, but this is like, I pull this on page 62. So we have our line, right? Y equals mx. As Patrick pointed out, in the previous example, that was going through the origin. This one is not going through the origin. So this point here is known as the intercept, right? Where is it intercepting the y-axis? When we're looking at a chart like this, we have our independent and dependent variables. Our independent variable is going to always be the x-axis. Our dependent variable is always going to be the y-axis. In this scenario, it's TV. The TV spend on advertising happens to be the independent variable, and the dependent variable is the sales, right? So in other words, if I have this level of TV spending, what are the sales that I can expect based on that use of the independent variable? So this is known as a scatter plot. So this scatter plot with all the little red dots tells us what they've done in the past. The line is the proposed model to say this model captures these lines or these data points the best. And the lines in between the 2 points, these black lines, that's essentially the error that has happened, right? Or some people would refer to it as the variance between what you would expect versus what actually happened. So coming back to the earlier question about RSE, RSE tells you what happened in terms of errors of your actual model or your training data. Whereas MSE, the mean square error, is more about what happened between your predicted values and your actual values. So that's why MSE and RSE are very closely related. but it's where you're pulling those errors from, those variances from, that differs in the two models. So I'm getting a little bit ahead of myself, but I just want you to kind of think about this chart where this is all we're doing. We have our independent variable, what we can modify. We can modify our TV spend, right? And then we know that it's going to have an effect on sales. And then this blue line tells us what we can expect. At a spend of 250, we can expect this level of sales, because that's what the model tells us, right? And when I say model, that's what the line formula tells us. That's what I'm really saying, right? So keep this all in mind as we move forward. But it's not really complex, guys. It's just little components that we're putting together, okay? So Mosin, thanks for joining us. I don't think I saw you in the chat earlier, so thank you for joining us. So M is scalar. Sure, it can be. Yeah. And we're going to get into that right on the next screen. But yeah, M is usually scalar, and I'm going to show you why. Okay. So the authors put together these questions for linear regression, right? And in these 6 bullet points, I'm like paraphrasing what they wrote. It's pretty close to what they wrote. You're going to find a pretty good relationship. But it's kind of like my interpretation of their questions. And I think it's a good set of questions to ask, definitely for linear regression, but really for a lot of models that you're going to have out there, right? So, is there a relationship at all between X and Y? Should be your first question. The next question is, how strong is that relationship? After that is, how much is the effect of X? How do you find what X is to begin with? Right? How do you know that TV spend has that effect on sales? Are there other factors besides X, like a Z factor, right? Because there could be more than one factor, right? And then, is there an interaction effect between X and Z that impact Y, right? Because when you start talking about additional factors that you're taking into your model, well, now those factors have an interaction factor with each other that you have to take into account, right? But these are 6 really good questions that I think the authors are proposing. And I take that one step further, and I basically kind of give you some notes here, because this is why I think it kind of relates to each other, or how it relates to data science, or why I say that you should be taking these 6 items and carrying them forward. Is there a relationship between X and Y? Well, that relates to model selection, right? Because if there is a relationship X and Y, you're probably talking that it could be like a supervised problem. So now you can really only look at supervised models, right? How strong is that relationship? Well, you're really talking about errors there, right? The stronger the relationship, the lower the errors. So that's really what you're talking about there. How much is the effect of X? Is the weighting, right? Because how much do you want to weigh that value of X? How much of a weight do you want to attribute to that TV spend? Maybe it's high, maybe it's low, who knows? When you're talking about how do you find what X is to begin with, or how do you find if there's other factors like Z, well, that's your feature search, right? When you're talking about, feature searches or feature engineering or data transforms, all that stuff, that's what you're talking about, right? What other things could be affecting my model? And then lastly, is there an interaction between X and Z? Well, that's model experimentation, right? Now you're going to say, okay, well, let me try these multiple models. Let me try different hyperparameters. I'm going to do some tuning on those hyperparameters. I'm going to do a grid search. I'm going to do some transforms. I'm going to, bring in other data, right? Like data, some data wrangling. Like, this is all how it ties together, right? So that's why I'm providing, the bold is obviously my notes on it, right? But again, I just want you guys to kind of take a step back and realize that everything in data science is correlated, right? Because I'm assuming you've seen some of these other items, right? Where you have articles or other tutorials or whatever that have come across about model selection or your errors or this or feature engineering or whatever, right? This is all the same thing. There are other terms, other ways for you to think about it, okay? Shravan says, when discussing model selection, are we referring to supervised or unsupervised learning? Shravan, that's a great question. I would say this is the second question. The first question is being able to recognize whether you're looking at a supervised problem or an unsupervised problem. And that's it. Just make a distinction between the two, nothing else. And like I said earlier, that's where your decision should stop. Because you might be able to say, oh, yeah, that looks like a linear regression problem. But that can turn into a form of bias because guess what? Now you're only trying linear regression models. There could be other models that work better, right? So so model selection, to address your question exactly, model selection would be step 2. And model selection is a process of experimentation, not of your own bias of, oh, well, yeah, this looks like it's regression, so let me only try regression, right? That's super dangerous, right? That's like a researcher bias. So love the question, Sravan, but it's step 2. Step 1 is recognizing what kind of problem you have. And step 2 is, okay, now I'm going to experiment and try to find that model. Okay? Great question. Love the question. All right, guys, so let me go on to the next slide here because I think the next slide is a good one here. So we're going to refine our previous formula. And this is the reason, and by the way, you'll note that I'm doing this slightly different than the authors, because the authors use like a beta value and things like that, which obviously is not incorrect. But y equals mx plus b is how they will teach it to you if you take a dedicated regression methods course. And if you're in a study program, you're probably going to have a dedicated regression methods course. But y equals mx plus b is a very common way to express a linear regression formula. So, as I said earlier, y is your dependent variable. What's going to change, right? Or what is dependent on that model. X is your independent variable, the thing that you can modify, that you have control over to change. M is what's referred to as your coefficient. And b is what your intercept is, right? Because not all lines pass through the origin, so you are likely to have an intercept value when x is 0. So that's what b represents. Okay? So y equals mx plus b should be something that you burn into your brain, because a lot of what you do, especially early on in your data science studies and in your career, all can be traced back to y equals mx plus b. Another reason why I bring this up is because every once in a while you kind of catch this in a chat or some sort of discussion online where somebody like me, like one of the older guys, will come back to you and say, well, everything in data science comes back to linear regression. Everything can be explained with linear regression. That's what they'll say in the chat, and then everybody else jumps on, oh, you don't know what you're talking about, old man, or okay, boomer, and all that other stuff, right? But they are correct. Everything does come back to linear regression. And the reason I say that is because it all essentially comes back to this formula. What are you trying to guess? Or what are you trying to predict? What are you using to predict? And what is the value? What is the weight that you want to assign to that variable? I guarantee you that everything you do in the future is going to be related to what I just said. What are you predicting? What is the factor that you're considering? And how much weight do you want to add to that factor? That is data science in its most simple terms. I mean, think about, we're getting way ahead of ourselves, right? But just to kind of prove this point, think about a neural network, right? What is a neural network? A neural network is a collection of nodes that sit there and do a formula, and they either activate or they don't, right? They sit there they take in some inputs with an activation function, and they fire or they don't, right? They activate or they don't. Same thing, right? They're taking in the items. The activation function says, okay, these are the factors, these are the weights. I'm going to decide yes, no to activate or not. But again, it all comes back to what are the factors you're giving me? How much weight am I assigning to those factors? And I'm either doing something or I'm not. So again, I want you to kind of burn this into your brain. Y equals mx plus b, super important for you to learn. Okay? Next chapter. Excuse me, next slide. I also just kind of make sure I emphasize this to you that I use y equals mx plus b, but I want you to recognize that you could have multiple factors. It's not always a one-to-one relationship with the factors. You can have multiple factors that influence the value of y, that influence your dependent variable. You can have multiple independent variables. Sometimes it's one, sometimes it's more than one. It just depends. Okay? To highlight again what we looked at, kind of just bring it all together, right? Sales is what we're trying to predict. We know that our TV spend is a big part of that. We know that M is some sort of weight, some sort of value we want to associate with that. But just to keep ourselves honest, it's called the coefficient. And then B is the intercept that you want to assign to that value. Okay? And then here, I'm just explaining it in a different ways, right? Sales is dependent, TV is independent, M is the coefficient or the weight, and then B is the intercept. But it's the same graph that we started off this whole discussion with. So not a lot of complex math, it's just a good model. And again, what are you trying to predict? What is the feature you're going to use to predict it? And how much weight do you want to add to that feature? Every data science problem you'll do in the future is exactly like that. All right, any questions before I go on to the next one? We're getting close to doing coding, so let me know if there's any questions. I'll give you guys a little minute here. You guys with me? Thanks for the assist in the chat there, Patrick. All right, give you guys another minute here if you have any questions. But we're getting close to using our coding here, guys. All right, good. Everybody's doing well. All right, so let's keep moving forward. This is from section, you can see here, 3.12 in the book. And I wanted to make sure I include this so that when you go and study later, you can tie this back to what you're seeing in the book. Because in the book, they talk about this in terms of the hypothesis, the null hypothesis and the alternative hypothesis. So here, look at this line here. There is no relation between x and y. That sounds suspiciously like one of the 6 questions we asked, right? Because it's possible there's no relationship. There's no model to be had. Right? So that's the first, that makes up your null hypothesis. And then your alternative hypothesis is that there is a relationship between x and y. And now you're trying to find essentially the strength of that relationship, the weighting of that relationship, right? So I just wanted to kind of bring this to your attention, 3.12, 3.13, because everything we've talked about, this is how it ties back to the book. All right? All right, so for the other question of how strong is that relationship, we're looking at your errors. And here we're looking at your residual standard error, which is again, pulling straight from the book here, average amount that the response will deviate from the true regression line. And the unit of measurement is the dependent variable. So in this case, the unit of measurement, staying with our example, is the amount of sales, right? That your model could be off by a certain dollar value of sales. And remember that here with RSE, we're talking about what it deviates from the true regression line. So in other words, you can almost think about like what is the deviation within your training data. Another item to look at is the R-squared value. And this, again, pulling straight from the book, measures a proportion of variability in Y that can be explained using X. Or you can also say it's the proportionate representation to show the fit between training data and prediction data. I believe this second bullet point is my own explanation. I don't think that's from the authors. But that's how I explain it. That it tells you how many of your, what is the proportion of your predicted values that can be explained by your training values. Right? That's a really important proportion to understand. So let's do some more participation here, guys. Okay? Residual standard error, and also the other one we talked about, the mean squared error, shows the differences essentially between your predicted values and your actual values, your model values. Right? So what makes up a quote-unquote good RSE value? Do you want that value to be high or do you want that value to be low? Same question for the R-squared. It measures a proportionate amount of explanation between your training and your prediction data, right? So what is a quote-unquote good R-squared value? Is it high or is it low? And is there anything special about the R-squared value? So give you guys a second to think about that. What do you guys think? All right, so Patrick has already volunteered an answer. RSE should be low, R-squared should be high. Okay, chat, what do you think? Do you agree with Patrick? Okay, Joseph basically gives the same answer. Low for RSE, R-squared should be high, okay. Okay, so Patrick says R-squared should be close to 1. So Patrick, you're hitting on that second part that I asked about, right? So guys, anytime you hear proportionate, you should always be thinking about values between 0 and 1. Right? So that's the first thing that should jump out at you when you see this R-squared definition. Proportionate is as a value of 0 to 1. So Patrick has obviously already hit on that. And he's talking about how R-squared should be close to 1. And that's exactly right. R-squared should be high, and it should be as close to 1 as possible. So you got it right. You got it right there, Patrick. Yeah, so basically everybody is getting the right answer. Rahul, thank you. Welcome to the chat. I don't think I saw you earlier, so thank you. So yeah, I mean, all of you are hitting on the right answer. You want RSE to be low, and you want your R-squared to be high. Because in those scenarios, RSE means you're making fewer errors, right? And R-squared means that your training model is very close, your predicted value is very close to your training values. Which means that the coefficients in the model that you chose to create your predicted values are very close to what's reflected in your training data. Right? So that's exactly why you'd want those. So everybody basically hit on the right answer. So Patrick says, can r squared be greater than 1? No, no, it's proportionate, right? So it can't be greater than 1, okay? Yeah, so I think in the next section we're going to be going to code. Yeah. All right, guys. So there's plenty more ways to measure the effectiveness of your model. I'm just proposing these to get us started off the ground, because again, this class is not going to get you ready for a job, but it is going to give you the foundation to go and research more and find out other measures that you could be using for your model. Okay? But R squared and RSE and MSE are going to give us a really good start to be able to say, okay, yeah, let's go ahead and research more, do a little bit more study. Okay? Okay. So here's the framework that I want to do, or that I want you guys to follow, right? What is a dependent variable we are trying to solve for? That's the first question you should be asking in any model. What is it that you're trying to predict? Second, do you have a linear regression problem on your hands? Because not everything is correlated in a linear way, right? Not everything is a linear regression problem, so you have to figure that out. And then the third thing, which is kind of like the modeling effort, is what are the factors that you should consider, and what is the weight you assign to that factor? Remember what I told you earlier about how you should, this part in bold is what you should be, burning into your brain. Because everything you do in data science is essentially that. So that's the framework that you want to kind of maintain, okay? All right. I'm seeing some questions in the chat here. Isa says, was wondering if we will get access to the slides. Yeah, maybe. I might do that on Discord. I haven't really decided that. Yeah, we'll see. But it'll always be on YouTube, Isa, so you can always refer back to it on YouTube also. Joseph says, I don't think R2 can be greater than 1 as it represents a fraction. Not sure. Yeah, that's right, Joseph. It can't be higher than 1. You want it as close to 1 as possible, but it can't be higher than 1. It's a proportionate value. It's values between 0 and 1, and that's it. The authors present the formulas for R squared and RSS if you're curious, but if you look at the formulas, it'll show you why it's not possible to be greater than 1. Okay? All right, so we look at the framework. So looking here, this is how we're going to work. What is the result that we're optimizing for? In other words, what is the value that we want to optimize for? What does the code look like? And like I said, we're going to be at least level 2 data scientists using an LLM, right? Ideally, we're going to be acting more like architects. And then 3 is that we're going to be code editors, not code writers. So we're going to do virtually 0 code on our own, okay? And this is what we're going to do for the lab. We're going to do a professional level development environment. We're going to create our own data sets. We're going to use some synthetic data for this. And I'm using that more as kind of like a warm-up for using ChatGPT, right? You can certainly have your own data. But just as a warm-up, we're going to create our own synthetic data sets. We're going to have code to solve for 1 independent variable, code for 2 independent variables, and then we're going to provide metrics for all the models. Okay? All right, so now we're getting ready to leave the slides. Do you guys have a preference on which version of Jupyter Notebooks to use? Drop it in the chat. That way we can set it up. But we're about to start doing some code, so drop the version of Jupyter Notebooks that you're recommending that we use for the problems, okay? I'll give you guys a minute to think about that. But let me know your preferred version of notebooks that we're going to use in the next section, because we're going to jump into code now, so let me know. Woo, we've been going for 2 hours, guys. Good job. I know a couple of you have been with me since the beginning, so thanks so much. Good job, guys. Okay, so Patrick is recommending Jupyter Notebooks within VS Code. What else, guys? Who else wants to give their preferred version of Jupyter Notebooks? Okay, so Isa says Jupyter Notebook comes with Anaconda. Okay, so whatever is the latest stable in Anaconda. Okay, anybody else? We're going to code next, guys. So we need a notebook. Let me know what you guys want to use. Anybody else want to give their favorite Jupyter notebook? Okay, Melly also votes for the one that comes with Anaconda. Anybody else? Last call. Last call before we go into code. Patrick says Google Colab. Amit says, sorry, I have been in and out watching while traveling. Hey, no problem, Amit. Really appreciate you staying with us. And you can always view the replay later, or you can join us on the following Sunday. We're going to be doing this for the next 8 Sundays. Or 7 Sundays. Today's the first one of 8. All right, no more Jupyter Notebooks. She says anything is fine. Amrapali. So Amrapali, are you voting for VS Code and notebooks? Or well, first of all, welcome Amrapali. I don't think I saw you before, but let me know which notebook you're voting for. Another vote for Conda, another vote for Google Colab. All right. All right, it looks like those are going to be all the answers I get. All right, guys. If you gave me an answer for your favorite notebook to use, wrong. You don't use notebooks. It's a trick question. My first bullet point is we're going to establish a professional development environment. Professional development in the real world is not done in notebooks. I know. That's a controversial hot take. I get it. Professional development is not done in notebooks. I will die on this hill. When you get out into the real world, you want to use some sort of IDE using some sort of terminal or some sort of other executing function. But the real world does not rely on notebooks. There's the old saying, and the old saying is still true, you can't deploy a notebook. Okay? So we are not going to use Google Colab or Anaconda or anything else. We are going to be using VS Code and then executing that code via a terminal. That is how you do professional development in Python in the real world. When you get out there, you're going to be working, you're going to be working with a lot more complex code. You're going to be working in distributed environments, a lot of different things, right? Where notebooks just don't cut it anymore. You might still use them to kind of like, as a scratch pad, and, just test some ideas on your own. But professional data science is being done in an IDE that's then executed within your own terminal, within some sort of other Python environment. Okay? Isa says, as a uni student, learning how it works in the real world is definitely insightful. Well, that's exactly what I'm trying to provide here to you, Isa. Because again, I see so much stuff out there, so many approaches to data science that, that are being, taught on other influencer stuff or tutorials. And again, when I see that, they tell me that they've never been in the real world, because this is how we do it in the real world. Okay? All right, so let's get going. So first thing I want to bring up, we're going to leave our deck here for a little bit. So first thing is I have Visual Studio Code set up with a blank environment, and I have my files ready to go here. I don't have any files, right? I'm just starting from a blank directory, and then we are going to execute our code here in this terminal window. right? And I'm using Mac, so this is using OS 10. But OS 10 mimics a lot of the Linux flavors that you're going to come across in the real world. So you want to learn something like Mac OS or Linux or whatever, because this is what you're going to be up against when people don't work. We had a discussion earlier about cloud certifications, right? When you don't have a cloud environment, or you're working in a server environment, this is what you're given, right? They tell you, okay, here's a command line prompt, go work with it, right? So really important for you guys to kind of get used to working like this. Visual Studio Code for your code, and then executing some sort of terminal. In this scenario, I'm executing locally within my own Python environments, but you would find this exact same interface if I was using one of my servers. So I keep a couple servers on DigitalOcean to help me kind of like do my own projects and my own ideas and stuff like that. But the interface is the same, right? I'm pointing out that I'm running locally, but you would see the same thing if we were to run this on my DigitalOcean servers or something else, right? The point is, you got to feel comfortable in Linux. You got to feel comfortable not working in GUIs, right? We're not going to see very many GUIs right now. This is just the way it is. This is professional development environment, okay? All right. So again, we're thinking in terms of architects, right? We are not just data scientists level 1. We're thinking of architects. So the first thing we're doing is we're going to need a file. We're going to need a file to create our synthetic data sets, right? Because we said we're going to need data. So let's create a new file, and we're going to call this datagen.py. And again, we're not trying to start with a blank screen, right? This is a blank screen. I don't want to work from a blank screen. I want ChatGPT to work from a blank screen, right? So now we bring up our friend ChatGPT, right? And so this is a limitation you guys might run up against. OpenAI has recently limited the amount of queries you can make of their ChatGPT 4.0 model. So I do have a paid subscription to OpenAI. I think it's $20 a month. So I understand not everybody here might have that, but I'm doing this because presuming that you're working for a company in a professional environment, you'll probably also have some sort of subscription to a tool. So I understand that as we go through this, maybe you're going to run up against the limit. That's okay. What they do is they let you go down to, I think it's either 4.0 mini, or they bring you down to 3.5. So you can still continue, and maybe the answers aren't going to be as great as they would be in the 4.0 model, but it's still good enough, right? Or you can use something else. I've also done similar exercises with Claude from Anthropic. Claude is also very good at generating code. In fact, I think sometimes it produces cleaner code than ChatGPT does. But they also have restrictions on how many you can make per every 4 hours or something like that. So I don't want you guys to get caught up in the tools, but I do admit that I'm going to be showing you some stuff that maybe you're going to run up. You're going to run up against the usage limit. So keep that in mind. Okay, so first I want to establish some context. So we're going to ask for a synthetic data set. And we're going to say, does this last part look familiar to anybody? This portion here? Isn't that y equals mx plus b, right? That's all we're doing, right? We're asking it for y equals mx plus b. And let's see what they come up with. Okay. Oh, let me get this out of the way. So now we're using our editing skills, and we're looking at what they provided here, right? So now we can modify this, and we want to make sure that it has a low RSC, right? So we need to refine our prompt here. Let's see if it creates that. Okay. What do you guys think? This code looks fairly reasonable to me. Oh, look, it even created it for us and has a download. It looks like they're using this noise variable to help minimize the low RSC, which is good because that means that we can play with that when we want a high RSC value, right? Because remember, we're going to want something that's a good fit model and also a bad fit model, right? So this would produce data that fits our model pretty well. What do you guys think? I think this code is reasonable to use. So I'm going to copy that code, and I'm going to bring it over to our data gen. Yeah, so I'm going to modify a couple things, right? Because for some reason it added a path, which I don't want. And just to make things easy, we'll call it low RSC and high RSC. And it also put in a range of X values, which I guess is okay, but I think 10 is too low. Let's go to like to 200. And the noise level is for a low RSC. So just to get an idea of what scale it's using, I want to see what high noise level should be. Okay, so they're using a noise level of 5.0. So now we know that if we use a 0.1, that should give us a low noise level, and a 5.0 should give us a high noise level. Everybody with me so far? What do you guys think? Does this code look reasonable to everybody? I think it looks fairly reasonable. So we can actually start to put this together in a way that fits our needs, right? And here we can say that we're going to modify this for a high RSC. Oh. So here we can go ahead and change this to 5.0. And this is high RSC. What do you guys think? Feel free to stop me or give me any feedback. But again, we know we're trying to do as little coding as possible. We're just doing editing right now. Let me know what you think in the chat. All right, this looks okay to me. We have a low RSC, we have a high RSC, we change the noise level. Melly is asking for a zoom in. Is that something that could help everybody? Is the code too small? Okay, it's tough to see the code. How about that? Is that better, guys? Let me know. I'm going to go one more zoom level in. Give me some feedback in the chat. Let me know if that's better. All right, Patrick says one more level. Okay. All right. Is that good, guys? All right, so it looks like we're back to good here. Okay, so we're playing with the noise level. A low noise level gives us a good RSC. High noise level gives us a bad RSC. And then we're saving it to two local files, right? All right, so I think I'm good with this code. So we're gonna go here. Let me know if you need the terminal bigger too. Okay, so it looks like our code ran just fine. So if we go back to Visual Studio Code, we now see our two files. We have our low RSC and high RSC, right? So that's what our high looks like, and then that's what our low looks like. All right, good. So now we have data to work with, right? So now we're going to start with our modeling. So now we're going to do linear regression, one variable, or one factor, we should call it. Okay? Again, blank screen, but that's ChatGPT's problem, not our problem, okay? So we're going to go back to our ChatGPT. And we're going to ask ChatGPT basically what code it knows, right? So it's telling you that it knows scikit-learn. And it's producing some relatively reasonable code. And it's plotting the results, which is okay if you're using a notebook, but not great for our code. And really, you know, again, guys, we're professional data scientists, right? We don't need plots, at least not all the time, right? So let's ask ChatGPT to modify the code. Let's use scikit-learn. MSC, RSC, coefficient, intercept, and R squared values. Let's pick up the R squared. Okay. What do you guys think? It even gave us a way to read the data set, which is wonderful, right? What do you guys think? This code look reasonable? Give me some feedback in the chat. What do you guys think? Actually, you know what? Let me bring it over to VS Code. That way it'll be a little bit bigger on everybody's screen. I just realized that. The part you can't see at the bottom is where it's just printing out the model items. What do you guys think? So Melly says, yes, it does for me. Okay, thank you, Melly. Appreciate that feedback. Anybody else? Patrick says it looks good to me. All right, you know, it looks good to me too. Let's try it. So again, we're just doing code editing, right? So now we are going to use our low RSC CSV file. All right, so let's think about this, right? We are data scientists, which means we're also critical thinkers, right? We're going to use our file low RSC as our input. What are we expecting down here, guys? Right? I mean, this is us forming a hypothesis, a theory, right? To help us understand whether our code is running right. So let's take some guesses or some educated guesses on what these results should be. What do you guys think? What are we expecting? Let me know in the chat. Give you guys a little minute here. But what are you guys expecting to see from these print statements once we run this code? Okay, so Patrick says RSC should be 0.1 as we set the scale to. Well, we set the noise to that, not necessarily the scale though, Patrick. So I think you're on the right track, but not quite there, right? It's not gonna be exactly 0.1, right? But you're on the right track. She says we should expect 10 and 7. Yeah, that's definitely the right track, because if we go back to our initial code, our initial prompts, excuse me, that's what we requested, right? We did y equals mx m7, I think. Yeah, right? We said y equals 10x plus 7. So that's exactly right. If we're on the right track, and that's to say if ChatGPT wrote the right code, right? Then yes, we should expect that our coefficient is going to be 10, because that's the weight we're adding to x. And 7 is our intercept, right? That's our b, and b is the intercept. So you know what? To remind ourselves of that, let's go ahead and copy that and put that as part of our our comments, right? Because we said y equals 10x plus 7. That's the formula we used, right? That's the model we used. So yeah, Ashish, you're definitely on the right track. And yes, Ashish also says that those should be approximate values. Absolutely, right? They're not going to be exact, because remember, we're still modeling. There's still going to be a random element to it, right? But we know we're on the right track if we're hitting these numbers. What about r squared? Did anybody provide r squared? What should we expect for r squared? Anybody want to take a guess at that one? Melly Durr says, I don't know. Hey, that's okay, Melly. We're all here to learn, right? So it's totally okay if you don't know. You know, maybe after these classes, you'll pick up some of these things, and maybe you'll take some of this code, do some experimentation on your own, right? And that'll help you learn. So it's okay if you don't know all the answers. We're going to get you there. But yeah. So what do you guys think for r squared? Anybody have a guess on what r squared should be? Give you guys a couple more seconds in the chat. Yeah, that's right, Patrick. So r squared, it's not going to be exactly 1, but it's going to be closer to 1. Yep. Yeah, Patrick corrected himself. Yeah, near 1. Yeah, it's going to be very close to 1, right? We should expect a very high r squared value. Isa says r squared close to 1. That's exactly right. We should be expecting a very close value to 1. Because remember, we asked for a low RSE, which means that the errors between the predicted and the actual are very small, right? In other words, that line and the dots are very close together, which means that your model, the model that should come of that should be very close to the training data. So that means on a proportionate basis, a lot of your predictions are going to be explained by your training data, which means that you should be high. You should be close to 1. So yeah, Amram Pali, that's exactly right. Amram Pali says r squared should be good towards 1 as it is low RSE. That's exactly right. Okay, so again, we're using this almost as like a check, because what if ChatGPT's code is wrong, right? We should be, kind of checking ourselves along the way, because ChatGPT does make mistakes, guys, right? So that's why I'm going through this exercise, so that we can kind of, run ahead and say, okay, yeah, that looks like a good result, or whoa, that's a terrible result. Where did ChatGPT go wrong? Because we didn't write this code. ChatGPT wrote this code, right? All right, so let's do it. Let's run this code. I think we're ready for it. Ooh, I didn't save it. So let me save this code. And then we're going to go to our terminal. Because we are professional developers, we do not use notebooks. Linear regression 1 factor dot pi. All right, let's see what happens. All right, coefficient of 9.999, intercept of 7.0, mean squared error of 0.009, residual standard error of 0.09, r squared 0.999. Let me know if you need that terminal bigger. But what do you guys think? Are we on the right track? Yes or no? Give me a yes or no in the chat, guys. I want to see as much participation as possible. Don't be shy. No wrong answers. But are we on the right track? Do these results look like we have viable code here? Joseph, you're asking a great question. Where can we learn how to work with an IDE and the command line prompt? Joseph, it's practice, my friend. It's just practice. That's really the only way I can tell you. I maybe, you know what, guys? Maybe I should write that resource, but I don't know any good resources that can teach you, like, from a level of 0 to do this. This is one of those things, like I said, I've just been doing it for so long, but I've been a professional software engineer from the beginning, basically. And I've been a data scientist for like the last 15 years. So this is just the way I've always done it. Like, this is the way professional code is done. So I wish I could tell you, oh, I learned from this book or from this tutorial. It's just the way I've always done it. I've worked in a lot of environments. I've had clients all over the world. I've been fortunate to work on a million different projects. And this is how it's done in the real world. So really, that's just like the only way I can tell you that you have to just kind of get out there and do it. Being on Mac helps because Mac has great terminals, and the Mac operating system, very closely mimics Linux. I think it started as one of the Linux variants, and then Apple has built upon it, obviously. But that's really kind of like the best way I can tell you. You just kind of have to do it. Okay, so Explore the Beauty says r squared should be close to 1, and we are, right? We're at 0.999. That's pretty close. Melly Durr says, I think so, as far as it looks good. Joseph Hernandez says it looks good. Isa says looks good and satisfactory. Amrapali says looks reasonable. Okay. Ashish, I answered this question on an earlier slide. Maybe you were just away from the screen, but go ahead and refer back to the replay on that, or maybe somebody in the chat will help you. Okay, so Amran Pali says it looks reasonable. Okay, all right, guys. So yeah, and I agree. It looks reasonable to me. We got very close to our coefficient. We know that our formula was y equals 10x plus 7. We got very close. Basically, we got to the intercept, right? We know the intercept was 7. Mean square error is as low to 0 as possible. Residual standard error is 0.97, which is good. R squared is 0.999. So yeah, these all look like very reasonable results. So this tells us that our code that ChatGPT produced for us is reasonable, right? Like we have functional code. So we can have faith in this code to go on and do more modeling with it, right? All right, so next thing we want to do is let's try our high RSE. So guys, what are we expecting here? Same question as before. What are you expecting here? What coefficients, intercepts, mean squared? What do you guys think? Remember, this time we're using our synthetic data set that has a high RSE. What do you guys think? What are we expecting? You don't have to do all of them. Just tell me what the R squared value we're expecting is. What do you guys think? Is it going to be 0.999 again? Yeah, Issa says, not comfortable working with terminals. We don't do it on Uni, mostly GUIs. Yeah, Issa, I get it. I hear you. It's a pain point. And maybe I'll do that. Maybe I'll come up with a resource to help you guys with it. Because, yeah, it's just the way it's done in the real world, And it comes back to that same discussion that we had earlier, right? Where people are talking about, oh, well, should I go for Amazon, Azure, Google certifications? Well, be careful, right? Because if you're saying, hey, I'm Azure certified, that might be telling a hiring manager, oh, this is somebody who always needs an interface to work with servers. They need an interface to work with databases, right? I mean, it's been a while since I looked at Azure, but Azure is very GUI based for their management, right? You want to be able to walk into an interview that says, yeah, I can work with Azure, I can work with Terminal, these are the different flavors of Linux that I know. You kind of want to have that flexibility in your resume, guys, okay? Okay, so Issa says R squared is close to 0. Amrampali says definitely low R squared. Joseph says low, maybe less than 0.7. Joseph says just low. Okay, guys, so I don't want to sound like I'm splitting hairs here, but there is a difference between saying it's going to be close to 0 versus definitely low R squared. And I think I tend to agree a little bit more with Amrampali, where we don't know it's going to be 0. The only thing we really know is that it's definitely not going to be close to 1, and it's going to be low. So I'm leaning more towards Amrampali's answer and Joseph's answer about low, maybe less than 0.7. Joseph, I would say it's even lower than that. I mean, I would say like 0.2. So again, that's kind of more Amrampali's answer, where, it's definitely going to be low. I mean, I would, if we were betting and we had an over-under, I would put the under at 0.2. 0.7, it's definitely going to be less than that, right? But you guys were on the right track, though. We know this is going to be a bad fit model, right? We know that we introduced a lot of noise into the data. So this is not going to be a great model, right? So yeah, let's go ahead and run it. So same code, we just use a different file. So I can execute the same line. Yeah. All right, so let's see what this gives us. All right. Oh, that doesn't look right. Did I not save it? Wait, what just happened here? Yeah. I did that. We're pulling from the high RSE. Okay, let's run it again just to make sure. All right, so this time we got coefficients that are actually, that are still reasonable, right? So we know that the modeling went okay. But this time we got a really high MSE and also a very high RSE. But the R squared is also high. Why is that? Anybody want to take guesses on why that is? Actually, I think I know why. I can see why we have that. Anybody else want to take a guess? Give you guys another second here in the chat. All right, what do you guys think? Patrick says, is it because we are using a linear model to model linear data? Yeah, in a way, yes. I think you're providing a good explanation. Amrampali says, is it pointing to the correct file? It is, Amrampali. So there's two possibilities here. Is that one, the file itself could be created incorrectly, right? Maybe we could look at our creation code again. But here's what's getting to me, guys. Look at the intercepts and look at the coefficient. The model still did a fairly okay job at figuring out what the coefficients and the intercepts were. So in other words, when ChatGPT created the synthetic data, it still created pretty good X values, but the Y values were still off. And that's why we're still getting very high mean squared errors and residual standard errors, right? Because, I mean, we got excellent values in the previous one when we knew we were using the low RSE file. But here, it still did a pretty good job of finding the model, but the mean squared error and the RSE are still low. Ashish, it has changed. It has changed from the previous file. Ignore this run here because this run is a repeat, right? But this is the previous run. This here is the run with the low RSE file. So it has changed significantly, right? That's a significant change in the MSEs and RSEs. So I think this is an interesting case here because ChatGPT did a good job of changing the Y values, but not the X values. Yeah, but I think that's why, Ashish, because the X values are still valid. It's the Y values that I think ChatGPT changed, or the code that it gave us for the synthetic generation that changed it. So here's what we can do, guys. We can go back to ChatGPT. And let's get a new generation for data. high RC and low R squared. Okay, that's interesting. It's using a really high noise level at this point. If you guys look at that, it went from using a noise level of 0.1 to using a noise level of 10, and we didn't do that in our previous code. We went from 0.1 to 5. So maybe that's part of the challenge. So maybe we should be doing it. Maybe we should be putting it much higher here. So that's one option for our change. What do you guys think? Patrick says maybe we can shift the location of our noise to add a systematic shift. Yeah, maybe. Let me show you something else, because here's what's also getting to me. I did a test to get ready for this course, and this is the code that ChatGPT had given me previously, where it's using the random normal distribution from NumPy and the standard deviations in order to modify the value of the code, or the value the value of the RSE and the R squared. So I have a feeling that it's also related to that. So here's what we're going to do. I have it for another. I have it for 2 variable linear regression, because I want to make sure that I show you a model that has multiple values for for factors, right? So it's not just y equals mx plus b, it's y equals mx plus mz plus b, right? So let's go ahead and use this one here, because this is going to give us for 2 variables. So let me bring this up to my root directory. Yep. So now it's going to be dataset gen for 2 variables. And let's relook at this code. And I like that. We're going to have different coefficients now. But you can see here how we have an x and we have a z value, and then we're still going to a y. All right, you guys with me so far? But let's go ahead and execute this code and use the files that it gives us. And I'm going to go ahead and move these CSVs to the archive, just so that we don't get confused. All right, dataset gen2 var. Dataset gen 2 var. Oh. Oh. I forgot a T. All right. All right, guys. So now we have this new data set with an X, Z, and a Y. And that's should give us a good RSE, and it should give us a bad RSE. So now we're going to ask ChatGPT for how to do this how to do linear regression with multiple values, right? So it's going to be this here. Oh, it thinks that we're still working with synthetic data set. So that's not good. Oh, okay. It's going to give us that too. Okay, great. All right, so let me copy this over. And I think I need to create the file on VS Code. I don't think we did that yet. Linear regression one factor. Yep. So now we need to create a second one. Linear regression two factor dot py. All right, let's drop this in. And we are going to be using the good RSE dataset. All right, guys, start putting in your predictions. What are we expecting? What are we expecting for these down here? Oh, did I not copy that correctly? That is a weird result. It forgot to do the include for NumPy. Oh, wait a minute, did I use the wrong code? What happened there? Wait, hold on a second, guys. I'm tripping over my own shoelaces, as we say. Linear regression two factor. Linear regression two factor dot py. And it's showing a problem in line 23. Yeah, that's weird. So it looks like ChatGPT made a mistake. It didn't give us the NumPy import. Everybody see that? Let me pause here and make sure everybody sees what we're doing there. Anybody else see the problem that we ran into there? You guys still with me? Hey, Issa, good seeing you. Safe travels. All right, guys, so that's a serious problem, huh? And this is exactly why we still need to have a pretty good level of understanding of code, right? Because ChatGPT will make mistakes, and this is a clear mistake on ChatGPT's part. It gave us code that didn't have the right includes at the top, or excuse me, the right imports at the top, right? So this is the stuff that we still need to be aware of, even though we're relying on ChatGPT to write code for us. So now let's go back. Our code is saved. We're not getting any more warnings, right? VS Code is not yellow. Let's see what this gives us. Okay, this looks reasonable. Coefficients of 3.8, 6.3. Is that reasonable for what we gave it? 3.8 and 6.3? Yeah, so 3.8, 6.3. You know, not the greatest fit, but a reasonable enough fit for 4x and 6z. And intercept of 15, intercept of 14.955. Okay, so pretty reasonable. What do you guys think? Yeah, you're right, Joseph. That's exactly right. It missed an import. So guys, really gives I'm glad this error came up, because it does set the tone for the importance of still, having coding skills and being able to edit when ChatGPT makes mistakes, because the mistakes will happen. And keep in mind also, this is the 4.0 model. This is their latest model. So I'm really surprised that it's making such basic mistakes like that. All right, but good. I'm glad that we were able to tackle both a one factor and a two factor problem, because you can see here that in this case, this line is the key one, right? This line is telling you that there's two coefficients that need to be worked through for this model. And then, of course, there's an intercept, right? There's not always an intercept, but in this case, it's telling us. So we got to the expected values. We got really good values for the MSE, RSE, and a good value for the R squared, right? So this is good. All right, so let's go back to our deck. We have hit all of the items that we wanted to hit during our lab walkthrough, right? Let's go to the next slide, because here is where I want to leave you guys with some self-study. First thing I want you to consider is, what does the code look like for additional factors? Maybe your model has 3 factors, 5 factors, 10 factors. What does that code look like? What about categorical results? We've only talked about scalar results, but we also mentioned categorical results. What does that code look like? We use synthetic data. Can you do this with real-world data? That would be an interesting challenge too, right? And then, if you really want to take it another step further, if you're really feeling ambitious, what does it look like with another framework like Keras? Because right now we're using scikit-learn, and we're using a lot of, NumPy code and kind of piecing things together. But there's other ways to do this, right? Like Keras can do linear regression. So what does it look like when you're using Keras? Because generally speaking, you wouldn't do it in the same way that I'm showing it to you here. You probably would use a framework. I'm more of a Keras guy than I am a PyTorch guy, but I'm pretty sure PyTorch can also do linear regression. So how would you do it in PyTorch, right? So these are the things that I want you to think about as far as next steps. So if you wanted to do some programming on your own, this is where I would extend it to. And keep in mind that when I say programming, I'm talking about ChatGPT. So yes, we kind of got snake bit a little bit right now by ChatGPT, but that's okay. That's going to happen. That's going to happen in the real world. It's going to happen to you whether you use ChatGPT or not. Or maybe you inherited somebody else's code and they made a mistake, right? So, you're still going to have to, have an editing mindset to be able to catch things like this, right? So that's where I want to leave you with the self-study. And, that's where we're going to pick up next week. We're going to move on to chapter 4 next week. So if you want to get ready for that. But I want to thank you guys for sticking with me. I know a couple of you guys were there from beginning to end. So thank you so much for that. I want to, give you another couple minutes here if you have any questions, because we've covered a lot of ground. But again, I think we've done a lot of really good work here. I think I've shown you how I want to manage these sessions going forward, because we're going to write very little code. We're going to write very little native code, right? And that's going to have its upsides, and it's also going to have its downsides. We saw one of the downsides today. But we got to roll with the punches, and we got to, fix the code, right? That's our job as data scientists, right? So I think you guys did really good. Got a lot of really great answers. I really want to thank you for all the participations. All the participation on all the questions. Really impressed by that. But this is where I want to leave you guys for self-study, and hopefully see you again here next week. Ashish says, "Thanks, Dennis, for the patience. Love the content." Oh, thank you so much, Ashish. Again, I'm just sharing what I love, what my experience has been. So if it helps somebody, then that makes me happy. So thank you so much for that feedback. All right, last call for any questions or any closing notes, guys. But thank you so much. This has been really fun, really interesting. So I hope you keep on coming back future Sundays. Again, this is how this is the framework that I want us to establish to work together. And yeah. Patrick says thank you. Thank you, Patrick. Appreciate everybody give a shout out to Patrick for helping me mod. Thank you so much for this, guys. Angel, thank you. Sravan, thank you. All right, everybody. So stay cool out there. It's probably hot in your part of the world. That's a pretty safe bet to say that. But yeah, take care of yourselves. Take care of your families. And I'll see you next time.